I am Jake. Most of you guys know me. I'm a B-tier CTFer. I also write a cyber blog. You can hit that QR code and you'll find me, or you can just look me up. I also run Kickstart with Cam Snyder, 5 o'clock on Fridays, and Crabtree 365 will turn you into a decent hacker. Not going to be the best, but you'll be all right. And I'm also minoring in Arabic. And no one who knows what they're talking about has ever accused the Middle East of being a simple place. So I've basically gotten a crash course in international relations, political science, economics, all of that, because of this little side. That has kind of coalesced into this presentation, which is 4 steps to it. And we got a lot of information to cover. If you're technical, you might not understand some of the international relations stuff. If you're an international relations kind of person, you might not understand the technical stuff. That's completely fine. It'll all come together in the end, hopefully. But we're going to cover supply chain attacks, how chips are designed, how chips are built, and then a theoretical case study on how a super sophisticated threat actor can interfere with some really important systems. So supply chain attacks, you know them, you hate them. If you were around in 2021, which I think is most of you, you remember this bad boy right here. So a supply chain attack is where they tend to be relatively sophisticated threat actors insert some kind of modification into the components of something. In this case, this diagram shows a software system, so perhaps it's some kind of dependency. The power of this comes from the fact that the farther upstream you're able to insert this vulnerability, the more devices you basically have like open season on. This chain of attacks, or this type of attack, is responsible for a lot of economic damage. So Log4Shell was a vulnerability that allowed for remote code execution, which is the kind of code execution that makes me keep up at night, on basically anything that was compiled with Log4j, which is a logging dependency, in the last 7 years. So there's a 7-year period that if you built something with Java, there's a good chance you use this, a good chance that you're now vulnerable to remote code execution. Let me get a howl from the dogs in the room. Oh, oh. Arctic Wolf labeled from their customer base about 90 grand cost of lost revenue dealing with this exact vulnerability. 90,000 times however many customers they have is a lot of thousands of dollars, perhaps more than I have. So this is kind of what people think about. This passes the litmus test of how bad things are when my mom knows about this. So let's talk about breaking something that's not like Minecraft, because Minecraft was vulnerable to this. But let's introduce our target. And as I go on the presentation, I want you to be thinking about how can we break this. If we were the Chinese government, and they love KPIs over in China, but you're the Chinese government, you're a hacker working for them, your goal is to reduce the effectiveness of the NGAD, which is the next generation air dominance platform. As far as I'm aware, this is just a spaceship. Like, look at this thing. And then this this smaller, closer to production ship a plane called the Collaborative Combat Aircraft. Notice there's no cockpit. This thing is a drone. These two are meant to talk to each other when the 6th generation fighter program kicks off. This is going to be an immensely complicated system with thousands, if not thousands, of chips inside of it. So now we have a target with a bunch of chips inside of it. Let's see what it takes to design one of these chips inside of them. The semiconductor industry is kind of bifurcated into 2 sectors. You have the design firms, which are the fabless firms, because the capital expenditure to actually buy the machines to build these chips and then run them is way too high. It's become profitable to only be the person that designs it. So we think you're like, I have a bunch of American tech giants here. So your Apples, your Qualcomms, Marvells, and AMDs, Broadcoms, NVIDIAs. Amazon, Google joins this number. Meta and Microsoft notably do not. They buy all of their chips from AMD. I don't know who, Meta is like allergic to producing good hardware. And then the other end of this is the foundries or the fab. You'll notice this is a lot more Asian in nature. This is the market share. We'll get to this big red bar in a second, but the other people that have the minority share is split up among four or five-ish companies. So that's SMIC, which is Chinese-owned Global Foundries, American-owned, UMC, Taiwanese-owned, and Samsung, which is Korean-owned. They have like, oh gosh, what is the number? Like almost a double-digit percentage of the Korean GDP in that company. But this is the big red bar, Taiwan Semiconductor Manufacturing Company. You'll notice this doesn't really look like Taiwan. This is the source of probably the worst roast I've ever gotten in my entire life. I showed this to Justin Applegate. He said, I don't ever want to hear you call me a nerd again. Not only did you recognize a freaking semiconductor fab from 30,000 feet, you took a picture of it and we're excited to show your friends. And I think that I think that's really valid. But TSMC is the Taiwanese semiconductor manufacturing company. They make every single they make I think like 90% of leading edge chips. The chips in your iPhone are made in Taiwan until very recently. A bunch of them are being made in this building right here. We'll get to some of the crazy devices they have in here once we get in a second. But here's some of the form factors they come in. You're going to see this slide again because I'm a hack. This is the first NVIDIA graphics card. This is the first 8-bit computer or processor, not a computer, but it's a processor, the Intel i8008. Here's an iPhone chip. This is a DIP form factor, a ball gate array form factor. This is a MEMS. These things are magic. Anyway, if you are, say, NVIDIA, you have like the 5090 or the upcoming 6090, or you're doing one of those like crazy Rockwell things, that you have to go through the entire design process where you get a bunch of nerds in a room and you design all the subsystems. And then once you design the subsystems, you transcribe that into a form of code called Verilog. And then you take the Verilog and you run it through a synthesis program, and the synthesis program turns that into a bunch of gates. Have I lost you guys yet? I don't think I have, right? Then you take the synthesis and then you run it through virtual environments, and you do like you run test bench suites. You got to test it to make sure the thing does what you want it to do. And then you prototype it potentially. This step is kind of optional nowadays because computers are really good, but maybe you put it on an FPGA, which is another piece of magic. Lots of magic going on in this presentation. But you can simulate hardware, not at the software level, but at the hardware level. I don't know how, but it's like genuinely this stuff is crazy. The rabbit hole goes insanely deep. And then you call up a fab. So remember, we're NVIDIA. We need someone to produce the best chips in the world. There's only one company that produces the best chips in the world. I mean, there's two, but like there's one company that produces the best chip in the world. So we're going to call up TSMC. Bad guy. I don't like the guy. I thought the picture was funny. And you say, I want access to your silicon. I'm going to give you a bunch of money. And then you strike the deal, the files get transferred over. If you're a cybersecurity person, that's where your alarm bell should be ringing. Your files get transferred over and you get something called a PDK. And the PDK basically is, it takes gates and then turns it into silicon. So we have let me go back. We have the schematic of what we need. Now we need to actually go through the process of taking these little chunks of like, kind of sort of CAD files in a way, and turn that into a computer and floor plan it. And then pretty soon you get to the chip fabrication process. This is heavy. So if you don't understand something, scale issue. No, I'm sorry. We all know Moore's law. Americans will measure everything in football fields and computational units it takes you to get to the moon. That was about right here. This is a logarithmic scale. So like this thing, like just the fact we can play Civilized 7 years ago, I was able to download on my 7-8-year-old phone and play Civilization 6 on it is just like wild because of Moore's law. This has set the pace of the semiconductor industry. You know, we all know the adage, for every 2 years for a given surface area on a chip, you'll have 2 times transistors, which is like 30% dimensions in each way or 60%, I can't remember. This is Gordon Moore, founder of Intel, kind of the father of the modern semiconductor industry. Anyway, ready, set, go. You take a bunch of sand. The purest sand in the world is in Spruce Pine, North Carolina, the only place where you can get this sand. You turn it into Minecraft sand, you light, no, there's supposed to be, oh no, there's supposed to be like the Minecraft sand and then like a fire GIF. You light it on fire and then lava. Where did that go? I'm mad about that. And then you dip that into a centrifuge, bish, bash, boosh. You start spinning it. You insert a seed crystal. You pull that baby out until you get a silicon ingot about 2 meters long. Nowadays, these things are, I forgot to mention, This is the final product. I would like you to be very gentle with this, or else I will do bad things to you. That is Aaron Hawkins. This is wafer. But
Do we want to maybe just have this somewhere during lunch and have people come up to it rather than pass it around?
it'll be fine. Gentle, be very gentle. Look how small those features are. Anyway, these things are about, that one's a 6-incher from the 90s. Nowadays, these cylinders are about 300 or 200 or 300 millimeters, which is bigger than 6 inches. Then you slice them, you polish them, okay, and then it gets complicated. There's supposed to be a picture here. I don't know what's going on. I'm blaming this on Mason, but you basically get a negative of the circuit you want to. This negative is called a photomask. And this is what they look like. These are insanely expensive, and you can print multiple and like super hard to manufacture too. So you can print like thousands of one chip with one of these. And then you coat the wafer in something called photoresist, which is like a developer solution. And when we'll get to this in a second, but when you shine a laser on the photoresist, watch it. I'm bonding the photoresist with the silicon right now. We'll get, and this is important because this machine is the craziest piece of technology you've never heard of. An ASML extreme ultraviolet lithography machine. Look at this. This makes it look small. This is 2.5 stories and probably 100 feet long. There's 140 of these in the world, and these are the only machines made by one company, held by one company, that are able to produce iPhone chips. Like he who controls the ASML EUV machines controls Arrakis. Notice there, like this doesn't. None of this looks cheap. There's an incredibly expensive light source. I'm going to say incredibly expensive a lot. That bounces through an array of incredibly expensive mirrors and then hits the photomask. And think about it, mirror. Like think about a mirror with duct tape on it. If I'm tracking along the mirror and then suddenly I hit the duct tape, it's going to stop bouncing. This is how you draw circuits on a piece of silicon. So it's kind of the development process. This is magic, guys. Like I'm trying to explain, it's just magic. And you'll see like the places where the mask is blocking out the lights is where it's not developing the photoresist. Then I missed a step. You got to wash it out, and then you got to dope it, which is you basically poison the silicon. You introduce impurities into it in order to make it semiconduct, which means it can either conduct or resist electricity depending on certain conditions. This is incredibly useful because now you've just made a transistor. Transistors are the foundation of any computer ever. So this is kind of what it looks like. I don't know what this means either, but silicon. Yeah, cool. And then you deposit copper traces onto it. It looks like a 3D printer. I think some of the technology is a little bit the same, but like at like nanometer scale rather than micrometer or millimeter and centimeter. You deposit the copper traces, and doesn't that look so pretty? I'm a big fan of these. These are at different scales. This is an individual gates. There's gazillions of these in your phone. And like this is the final product. This is called a die. So now the die, look at that, it's so tiny. Now you gotta slice the dies or dice the dies, depending who you ask, and then you put it in the package. You put tiny itty bitty baby solder wires into it to connect it to the lead frame to the outputs of the actual chip. And you've seen the slide again. Now you have this. You can see why this is an incredibly capital intensive process. You need a lot of very specialized knowledge. You need a lot of engineers and a lot of chemists, a lot of everybody. Like we harp on this a lot, but by goodness, is this difficult to do? Now you got to take the chip and you put it on a PCB. This isn't a very good picture, but this is a pick and place machine. And when they talk about like countries that tend to build electronics, so that's your Chinas and your Indias and your Bangladeshs, Indonesias, all of them. This is kind of what they're talking about. All of this happened in Taiwan. That's pretty important because Taiwan has made themselves incredibly invaluable to both the American economy and the world economy. So let's threat model this. Woo! So imagine putting all your eggs in one basket. That's a terrible idea, but All right, remember our target is NGAD, which is the next like 6th-generation fighter aircraft meant to kind of sort of replace the F-22. Again, this thing's a spaceship. We don't know much about it. Allegedly, a couple demonstrator flyers have been flown. I'm not an expert in this field. So, quick geography lesson. China, big, far away. Taiwan, small, very close to China. Taiwan doesn't want to be part of China. China wants Taiwan to be part of China. Remember, it's not a great idea to have your massive, super incredibly valuable supply chain on an island that's like the size of Logan to St. George, less than 100 miles from, I would gander, the second best military in the world. USA. Remember, this is our supply chain. ASML is the only company that's able to make extreme ultraviolet lithography machines. TSMC is by far their main customer. Now, if you are Lockheed Martin and you're putting in you're designing NGAD right now, you're buying chips from Broadcom, or maybe you're buying them directly from TSMC. Likely you're going through the middleman here. We in the cybersecurity industry tend to think about this link a lot. We tend to think about we think less about this link a lot, but I'm not sure. I'm really hoping that Broadcom is thinking about this link and TSMC is thinking about this link. That means we got to trust 5 separate organizations to make sure that no one is inserting things into our chips. So wait, what's next on my slides? Am I crazy? Oh yeah, never mind. So the power of this is, remember what I said about supply chain attacks, is like if you're the Chinese government and you have like basically the best hackers on the planet, very like, in my opinion, peer to the United States, this pair of companies produces an incredibly juicy target because these guys supply all the chips in the world. And if you're able to hack into one of those lithography machines, or maybe the machines that make the photo mask, or maybe, how am I doing on time? Maybe if you're able to hack into machines that do the lithography or the machines that make the photo mask, you can alter the circuit to do something. Like, all right, hey, imagine that your goal is to reduce the range of the NGAD. What you could do is you could figure out which chips are affiliated with the fuel injectors, or maybe just the engine themselves made by Pratt Whitney, and have some kind of like implant some kind of behavior into it that you press the big fat red electronic warfare button, and then suddenly their burn gets increased by 10%, reducing their range by a significant amount. Now these NGADs can't cross the Pacific in one go. That's huge. Like, if you care about the same things that I care about, if you care about like, say what you will about the American military, I don't think it's a great idea for there to be a big red electronic warfare button that turns our weapon systems off, especially when what's on the line is probably the most important island in the world, except for the one that my sister is serving a mission on right now. Please don't nuke that, guys. Taiwan has made themselves absolutely indispensable to the United States, and I'm interested in protecting it because we saw what happened with COVID when the chip supply chain got disrupted because of COVID. Everything got more expensive, like especially automotive. I like driving a car. I'm a blue-blooded American, and we need to keep this little chunk of land safe. So if you have any questions about this, I trust these guys with absolutely everything. I kind of arranged this from semiconductor to sinology. This is sinology means study of China, I think. This is Dylan Patel of Semi Analysis. He does like semiconductor analysis. I think he's like a boutique advisement firm. I don't know. I'm not sure about the business model. John Y of Asianometry. He's like I think he's an electrical engineer by trade, and he just does like the nerdiest things, nerdiest videos you could ever imagine. And then of course, Jordan Schneider of China Talk. So yeah, all right. That's all I got. Any questions? Yeah, Brett, what's up?
Yeah, that picture you took from the airplane of the fab.
Yeah.
You didn't mention where it was located.
Oh yeah, it's in Phoenix. I forgot about that. Yeah, so that's over by my oh yeah, look at that. I figured I'd get like this is a block away from my old office in San Francisco, but Let's see, yeah, this picture right here, yeah, this is about like 45 minutes out of Phoenix. This is TSMC did an incredibly intelligent thing. They injected $65 billion and created thousands of jobs in a swing state. So they're kind of untouchable, is what I would have said a week and a half ago. But things have been changing very rapidly. I don't know if you pay attention to the news. So any questions? Yeah.
What's in the news?
Trump was like, hey, they stole the semiconductor industry from us. True, actually, we need to tariff them. And like, I would gander everyone at TSMC was like, we just did this with $65 billion and then more on the way, probably. Like, it's just, it blows my mind. But yeah, maybe it'll work. Maybe we'll have domestic semiconductor industry producing all of the chips that we need, both in a military and a commercial setting, at a faster timeline than we thought. I think the timeline that the Biden administration back when they were putting together the CHIPS Act was like 25, 30 years. I could be completely, absolutely wrong about that. But yeah. Okay. Any more questions?